next speaker, Mitesh Sharma. So, welcome Mitesh Sharma for OSCON 2021 live. So, Mitesh Sharma has more than 10 years experience in the software industry. And during his time, he has been worked in startups and built a lot of end-to-end products. Currently, he's working in Rudderstack, which provides open source data pipeline software as an engineering manager and managing DevOps with their multi-tenant offering. A warm welcome. And the topic for the day would be managing multi-tenancy at Rudderstack using Kubernetes. Mitesh, we are not able to hear you. Are you muted?
Yeah, sorry, I need to restart Chrome quickly. Actually, I'm not able to share without that. Oh, but 1 second, I'll join back.
Yes, sure.
Okay.
Meanwhile, I would like to say the audience to, feel free to post your questions on YouTube channel.
Can you see my screen?
Yes, we can see your screen.
Okay, nice. Should I start? Yeah. Hi, guys. This is Mitesh from Rudderstack. I am basically like managing the multi-tenant stack there. So I'll be talking about how we built the complete multi-tenant system and why we needed it in Rudderstack. So let me start with just giving a basic intro about what Rudderstack is, and then go deep into the tech stack. So the first question is why there is a need of such a product like Rudderstack. One of the thing is consumer data volume is continuously growing. If you see every month around 60 to 65% of data get like increased for a company for consumption, and it's not only growing, it is growing at multiple sources. At a very early stage startup, how it starts is basically you start generating data from your app, then you start showing ads, and then you need to collect data from different ad platforms. And as company grow and you reaches to more of an enterprise state, the data get distributed across multiple sources, and collecting them, getting value out of it become very critical. Even at this point of time in 2021, like around like more than 80% like executive believes that they are not able to get the complete value out of it. Now, as data is distributed across multiple sources, collecting them, putting them into their warehouses, putting AI model, doing some analytics on top of it, and sending it at different places becomes really hard. And this is a real problem which needs to be solved. So Rudderstack comes into picture here and is a like smart consumer data pipeline. What we do is we simplify the process of collecting data from multiple sources, processing it, getting a governance on top of the data. At the same time, don't persist the data like on our side. We are completely open source. The complete code is available on GitHub/Rudder Labs. And currently we process more than 35 billion events per month. This is just a rough number which I know of. As we are open source, a lot of people are using it and we are not even aware of that number. So that must be like pretty high. What is our aim? Our aim is to like help companies solve their data problem. They don't need to build code for every source and write the complete data pipeline again. So we are exactly coming and solving this problem. So if you can see, a very basic example is you can start integrating the Rudderstack SDK into your mobile app, and the data will, and you can define any destination. It can be one destination or can be n destination, and data will start flowing to that destination. Along with that, you can add data transformation or do data governance on top of it. Now, how we started as an open source company. Then we moved to more of an enterprise model, and eventually we move, and as lot of customer asked us that they don't want to deploy it on their infrastructure, we had to start deploying it and provide a hosted solution. And as we started from a single tenant model, going to a multi-tenant model becomes really tricky. So let's first see what is multi-tenancy. Multi-tenancy means deploying the software in a shared environment so that the same infrastructure can be shared by multiple people. But at the same time, we don't want tenant's data to be exposed to any other tenant. It needs to be isolated, and basically the complete environment of tenant should be isolated from other tenants so that they can get security. They have confidence while running their passing the data through our stack. So we need to understand like why there is a need of multi-tenancy. We can even provide like everyone their own individual environment and they are like good with it, right? Like from a customer point of view. But we wanted to, so like for a developer don't want to talk to a salesperson. He just want to try an open source software, and maybe he want to go with a hosted solution. So in those cases, we want to make this process completely simplified. And to simplify the process, we are providing a self-serve model. And building a self-serve model without multi-tenant system is really hard. What multi-tenancy enable us? It enable us to reduce the hardware cost, because now we are able to share databases. We are able to share underlying resources. It gives us a long-term like cost saving. It helps us in maintenance, because now we don't need to go and do an isolated maintenance for each and every tenant. And for ops team, it provides velocity. Like in the current environment, getting velocity from the ops, like DevOps side or SRE side, becomes really hard if there is a 1,000 separate deployment. It also improved the quality of software, because as there are a lot of customers sharing the data, whenever one fix goes to one customer, it automatically goes to all the users sharing the same infrastructure and sharing the same software. And specifically for Rudderstack, where the spike for one customer is not at the same time when the spike is for all other customers. So let's say there are 10 customers who got spike at 12 a.m. and 10 customer who got spike at 12 p.m. With the same amount of infrastructure, we can easily provide them service without increasing and reducing resources every time whenever we get a spike. So let's now go back deep into how the setup is done, the complete from ground zero. Now, what we did is, for our multi-tenant environment, we are using AWS EKS. The benefit of using cloud provided solution is we don't need to manage master nodes. That is automatically managed by AWS for us. We first run the complete code using Terraform. We provide a network layer. Once the network layer is done, we set up AWS EKS on top of it so that the Kubernetes environment is ready. Once that is done, we set up some basic pods which are needed for setting up the complete infrastructure, the complete application management layer. Once that is done, then next comes into picture the deployment of our application. And also manage. So we also use a custom operator which helps us do the deployment for each and every tenant. I'll go deep into how operator works and what it does in future slide, because that plays a critical role in our infrastructure. So we use Argo CD for the complete deployment of all the application. So it provides us benefit of going with a complete JTOPS model. So everything is pushed through JTOP, and it will automatically get synced to our Kubernetes cluster. And eventually Argo CD also manages itself, so that whenever we need to update it, we just again push a code into JTOP. So everything becomes auditable. And during the complete setup, security is at core, because consumers' data is flowing through our pipeline, and we can't let anything happen to that. We can't let anyone spoof on the data. So that way, security is at the core. Security is one of the core principles for us. Now let's go deep into how the Kubernetes cluster looks like when it is going to provision. So what we do, first we need to provision some controllers which can help us create the resources create the needed service setup. So if you see it is divided. The first one is to manage the external dependency. So one controller which we use is external DNS. It helps us manage Route 53 directly through code. So we don't need to, we create a custom resource and we tell Kubernetes, let's set up this custom resource. In the custom resource, we already tell Kubernetes using annotations that let's set up a DNS route for a given customer. And external DNS controller keep a watch on those annotations, and it set it up for us on Route 53. How it is done is we use IRSA. So with the help of OIDC, every pod, so that is basically to give every pod AWS role at runtime. So that way we don't need to like provide the complete role to set up Route 53 at instance level. So with that, whenever some requirement comes, the external DNS controller is always listening. It get to know, oh, I need to create a new subdomain. It has required role, and it directly make a API call to AWS and set up the Route 53. Similar second thing which we use is ALB ingress controller. So we are using 2.0. The benefit of using the latest ingress controller is basically it helps us share the ALB across multiple customers. And with the group, we can separate out like customer, and we can define who all customers are going to use what ingress. It basically reduces our cost, because if you are providing separate ALB for every customer, it's definitely going to increase the cost. But at the same time, it gives us flexibility that we are able to, like, we are anyway paying for the traffic. So that way we don't need to pay extra cost for like a basic ALB. Then third is we need to set up a EBS CSI driver. So previously we were using the default EBS driver, which comes with Kubernetes EKS. But the problem is sometimes we were seeing like disk were getting like PVC's issue with PVC. So now we moved to EBS CSI driver, and it is going good for us. Once this basic setup is done, the next thing is about scaling the cluster. We don't want to go manually add instances to the cluster whenever a new customer comes in, or a pod we are increasing the number of pods. So for that, we used custom autoscaler. It helps us automatically scale the infrastructure, underlying infrastructure, so we don't need to worry about it. But at the same time, we use cluster over provisioner. What it does, it creates some dummy pods so that we have some extra space already available. So this is some extra resources which is consumed, but we are like not as it is used. So what happens whenever a new tenant come, we can consume this extra spaces which are consumed by pod with a given amount of resources. These pods are at very low priority, like they are at -10 priority. So whenever a new tenant come and we need to provision resources for that, these are the pods which will evict immediately, and they trigger auto scaling of cluster. But at the same time, we are able to create required pods for the customer. Then we have our own custom Rudderstack operator. This is the key element for the complete infrastructure. And we need to set up a lot of application services. When I say application services, it is more like application, like the user application, the billing service, tenant service, and all those kind of services. And the complete monitoring is done through like tick stack, where for graphing library, we are using Grafana. And if you see the complete deployment, everything is managed through Argo CD. So we have like Google Auth, and we have required permission set up for every user. So that way, like anyone can go see, and the complete deployment, like whenever someone need to do push, they can just like push it to GitHub and it will be auto-saved. Now let's see how the tenant onboarding works. What happens when a user comes to the Rudderstack website and he log in as a cloud user? So now from a user point of view, whenever user is going to come to our website and he's going to register, but underlying we are doing lot of heavy lifting for a user to set up the complete multi-tenant environment. So when user comes, we first register the user. We create a tenant for the user. So every user will have a workspace. Now for that workspace, we have one tenant that define that workspace. And for every tenant, we define billing as well as deployment. So we make a request to billing service, which basically automatically assign a zero amount billing with Stripe, which helps us simplify our complete billing management. At the same time, we make a request to deployment service, which defines what all needs to be done for this user. So for a free tier user, like we already have a hosted environment. So in that case, we don't need to go and create the multi-tenant environment. But once user pay, we definitely need to interact with Kubernetes APIs and set up the complete infrastructure. So from if you see when everything is done, like user make a request, we send the request to deployment service. The complete multi-tenant environment looks something like this. In this case, we have some of the pods which are dedicated to user, because we don't want to provide any kind of degraded experience to any user, even if some user is on heavy load. So that way, like everyone get some pods which are like dedicated to them. But at the same time, we have some shared resources like databases. In case of database, we have every user will have their own like username and password and their own database, and no one else have access to that database. Only this particular user can access. Also, there are some shared services which you like which we run, which is independent of this, which are like automatically horizontally scalable. So that way, like whenever more request comes, those services automatically scale, but they are shared across all the users. Now let's go deep into how the deployment works in terms of like deployment service, because that is going to be core for us. Request comes to deployment service. We create a user and a database. We make a request to our Kubernetes operator to create custom resource. The operator make a call to Kubernetes API, and then like we have a dedicated namespace for a user, and all the pods are getting created. So let me go deep into operator, because this is the heart of our multi-tenant environment. So just to see what is an operator. So operator is a software extension for Kubernetes. We can write how to package, how to deploy, and how to manage our application. So basically what it does for us, it hides the complete complexity. The complete logic of deployment, scaling, managing the application is inside operator. We just make a request with a custom resource to our operator that we want a user with these resources, and the complete heavy lifting is done through operator. How operator works? Basically, operator watches on a custom resource object. It, with the help of Kubernetes API, it sees what is the actual state and what is the desired state. If there is a mismatch, it basically act on the change, and it try to reach Kubernetes, like the pods or the resources, to a desired state. So in our case, what we do is we make a request from deployment service to Kubernetes API. Operator is watching on the custom resource, it gets the request, and eventually it creates all the needed pods. So why we need operator? Like basically, like for a stateless service, there is no need of operator. So one of the reason is we are using lot of stateful services, but at the same time, we have the complete logic of scaling up and scaling down inside operator. Now, if you see for a simple application, like it is a very simple logic. You can just increase the number of pod. But in our case, one of the critical thing which we provide is ordering guarantee. Now, in case of ordering guarantee, if you just add more number of pods, there is a chance that ordering guarantee will mismatch, that some of the request for a given user will go to some other pod. So to do that, we need to create a completely new deployment and put it in what we internally call degraded state. So in this particular state, the new deployment start receiving the request, but it doesn't process unless the old data is already flushed. So if I go step by step, we first create a new, whenever we need to scale up or scale down, we create a new deployment. We change the ingress to the new deployment. So all new events will go to the new deployment. We wait for like that, whatever data is flushed, it is fine. Whatever the remaining data, we migrate it to the new deployment, and we finally delete the old deployment. So let's go deep into it, because this is something which is pretty interesting. So in this, if you see in this case, we already have 2 Rudderstack pods running, and they are managing specific fixed number of users. Like user 1 is going to a particular Rudderstack 1, user 3 is going to Rudderstack 1, but at the same time, user 2 is going to Rudderstack 2. Now, when we scale, we create a completely parallel deployment. We assign every user to a pod, and we migrate the complete incoming ingestion of data to the new pods. Now, this data is not getting processed, but only received. We migrate the complete data from the old cluster deployment to the new deployment, and then we delete the new deployment and migrate our new cluster to more of a normal mode. And same thing we do with the downscaling of resources. So what advantage this gives us? One is the migration can happen from one cluster to another cluster. It can even be done from one region to another region. So it gives us a lot of firepower. Like we can do anything with the cluster without providing even a single amount of downtime, because even there can be some amount of delay because during the migration, but that is very minimal because everything happens through code. So if on a holistic view, if I see how our operator looks like, we are using Helm charts to deploy specific resources for a user. that is embedded inside the operator. Operator run those charts, set up the complete environment, monitor it, watches on top of it. It also deploy shared monitoring for users so that we can provide a specific dashboard for a particular tenant. They can watch the resources, how they are behaving. At the same time, it also deploy all the needed, like it set up databases. If we need to run Postgres as a pod, it create that and those kind of things. So once everything is done, how it is going to look. So eventually the complete setup looks like this. The request will go to Route 53. It checks, it gets the domain, like it resolves it to the ALB ingress. Then eventually request will go to ALB ingress. The data will go to specific pod where it needs to be go. Like it interact with some of the shared resources. Eventually it goes to the warehouse, either warehouse or this defined destination for a user. So this is a basic intro about how our multi-tenant stacks look like. Yeah, I think I can take questions. Hello.
Yes, we can take some questions now. So the first question is, can we deploy multiple tenants at the same time and with tagging, and is there an issue with the production environment?
No, we haven't faced the issue like this. Like basically, we just make a call to the operator, and operator makes sure that all the tenant is getting created. But in our use case, it is not like a normal B2C use case where thousands of users are coming at the same time. Basically, there are less number of users, right? And they are paying user. So whenever they make a request, even if the requests are concurrent, we make a call to Kubernetes API and they are done parallelly.
Okay, in that case, you don't have any, is it the deployment in batches, or how do you execute that?
We haven't implemented in like batches because till now we haven't seen like any issue by making multiple API requests for deployment at the same time. So it is not like we are doing 100 deployment at the same time. It is more like 2 or 3. So in those cases, like request, we just make a request to API and operator manages it internally. So operator itself has a queue where it takes, like it watches and it takes the resource, it manages it.
Okay, and is there any licensing impact if we have multiple tenants, or and the last question is there any limitation for all this? Non limitations.
So we are using Postgres, and there is no licensing limitation in terms of Postgres. Like, and other than that, we have our own custom resources. So that way, the complete like everything is like there is no licensing impact as such. Yes.
Okay. So yeah, I think we answered. We have taken up all the questions. So thank you, Mitesh, for the great session and for walking us how we can manage multi-tenant along with all the security aspects for same. Thank you again.
Yeah. Thanks.